Assalamu alaikum kids. Inshallah, in this video we'll talk about the Newton's laws of motion. So let's talk about the first law of motion. The first law of motion states if an object is stationary or moving with constant velocity, it will continue to do so until an unbalanced force is applied. Now, this term unbalanced is there for a reason. It's very important. We'll define force first, and then we'll come back to this and discuss what the word unbalanced means. The first law of motion is also known as the law of inertia. Well, what's inertia? Inertia is the ability of an object to resist the change in state of motion. Well, there are two states of motion. One, when an object is moving, the other, when an object is at rest or stationary. Change in motion is either making a stationary object move or it's making a moving object come to rest. Either one. Now, think about it. What do you think is going to happen if you have someone standing on a skateboard and someone suddenly pushes the skateboard from behind? Well, of course, the person is going to stay where they are and the skateboard starts moving forwards, and because of that, that person is going to fall. That's because your body does not want to move. It's resisting the change in state from stationary to moving, and hence your body stays where it is, while the skateboard moves forward and causes the person to fall. Moving on to the second law of motion. The second law of motion states acceleration is directly proportional to the applied force. F is directly proportional to A, where F is force and A is acceleration. The formula using the second law of motion is F is equals to m times A, where F is force, m is mass, and A is acceleration. Well, the conclusion is that if you apply a greater force on an object, it's going to accelerate much faster. Example, if a car has a larger engine, the engine's going to apply a greater force and hence accelerate faster compared to a car with a smaller engine. Since we used mass in the formula, let's define what mass is. Mass is the amount of matter in an object. It's a scalar quantity, and the units for mass, the SI units rather for mass, are kilograms. Using the information above, we can easily define force. Force is defined as the product of mass and acceleration, though in normal language we can define force as a push or a pull. Now, force is a vector quantity and its units are newtons. It's a very commonly asked question that we want to define what a newton of force is or what 1 newton is. So the definition of 1 newton is it's a force that accelerates an object of mass 1 kilogram by 1 meters per second squared. The third and the very interesting law of motion is every action has an equal and opposite reaction. A lot of concepts in physics are derived from this law, so it's very important to understand this one. Now, because action and reaction formulate a pair, so we need to understand the action-reaction pairs. These action-reaction pairs can be experienced quite regularly. Example, swimming involves the action of pushing the water backwards, and the reaction is our body being accelerated forwards. The backward force applied on the water is the action, and the forward force applied by the water on our bodies is the reaction. Likewise, a helicopter pushes the air downwards to move up. This is the result of an action-reaction pair as well. The action is helicopter pushing the air downwards, and the reaction is the helicopter moves upwards. Another very important concept is of a book resting on a table. A book has weight acting on it downwards, but it actually does not move downwards because of the reaction force upwards applied by the table. The specific reaction force against gravity is known as the normal contact force. Any object that has weight acting on it downwards, but it's resting on land or moving horizontally, has gravitational force counteracted by the normal contact force. For example, a car that's moving on a road at 80 kilometers an hour has a very large weight acting downwards, but the normal contact force prevents the car from sinking into the ground. So the three laws of motion actually help us quite a lot in physics. The first law of motion helped us in defining inertia. The second law of motion defined force, and the third law helps us see the relation between the action and the reaction pairs. We are going to use these three laws quite often in the upcoming videos. That's it for this video. Inshallah, I'll see you in the next one. Bars out.